Good afternoon, third grade online learners. Welcome to March 17th, St. Patrick's Day, with me, Mr. Monzo, here in science class at Level Green Elementary. I'm going to toggle over on my computer, and this should keep recording. And I'm just going to read some highlights of the website, and then my good friend Levi Hudak is going to read his summary. Okay, so let me just go to the website for a second. All right, so we are talking about matter, and I went on to a website called Britannica Kids. And they start talking about matter by saying an electron, a grain of sand, an elephant, and a giant quasar at the edge of the visible universe all have one thing in common. They are components of matter. Matter is the material substance that makes up the physical universe. A beam of light, a motion of a falling stone, and the explosion of a stick of dynamite all have one thing in common. They are expressions of energy. Energy and matter together form the basis of all observable phenomena. The states of matter. And this is a very large article, so we're just going to do some of it. Most of the matter that people ordinarily observe can be classified into one of three states or phases: solid, liquid, or gas. Solid matter generally possesses and retains a definite size and shape, no matter where it is situated. A pencil, for example, does not change in size or shape if it's moved from a desktop or placed upright in a glass. A liquid, unlike a solid, assumes the shape of its container, even though, like a solid, it has a definite size or volume. A pint of water changes its shape when it's poured from a glass into a bowl, but its volume remains the same. A gas expands to fill the complete volume of its container. A given temperature and pressure, a substance will be in the solid, liquid, or gaseous state. But if the temperature or the pressure changes, its state may also change. A constant atmospheric pressure, the state of water, for example, changes with the changes in temperature. Ice is water in the solid state. If it is removed from a freezer and placed on a warm pan, the ice warms up and changes to the liquid water. If the pan is then placed over a hot fire, the water heats up and changes water vapor, the gaseous state of water. Most substances can exist in any of these three states, provided they do not decompose chemically, as sugar, for example, often does when it's heated in air. Oxygen must be cooled to very low temperatures before it becomes a liquid or a solid. Quartz must be heated to a very high temperature before it becomes liquid or gas. In most people's experience, wide changes of pressure are not common as drastic a change in temperatures. For this reason, examples of the effects of pressure on the states of matter are not common. Often, high-pressure machines in vacuum, low-pressure machines must be used to study the effects of pressure changes on matter. Under very low pressures, matter generally tends to enter the gaseous phase. At very high pressure, gases tend to liquefy and liquids tend to solidify. In fact, at the very lowest temperature that can be reached, helium will not solidify unless a pressure of some 25 times the normal atmospheric pressure is applied. The relation between pressure and temperature in changes of state is familiar to people who live at high altitudes. There, the pressure is lower than at sea level, so water boils at a lower temperature. Cooking anything in water takes longer on a mountaintop than at sea level. These properties of the three states of matter are easily observed. They are explained, however, by a theory that describes the behavior of particles far too small to be seen. So this article goes on to talk about the atomic theory of matter. That's pretty scientific. The atomic theory and the states of matter. And this is for kids, surprisingly. The fourth state of matter, which is plasma. Then it talks about inertia and gravity and Sir Isaac Newton, gravitational pull on the earth, properties of matter, chemical properties, modern theories of matter, mass of radiation, wave properties of matter, the building blocks of matter, antimatter, string theory, and some additional reading. So as you can see, this is a very, very extensive website. And if you're interested in this, there's lots to read, and there's also some links to click on. So, often we summarize, we only get to the first paragraph, but there's so much more here. All right, so I'm going to ask Levi Hudak to come up, and Levi is going to read his summary of this website. Come on up, Levi.
Oh. Should I read them what's on the board too?
Whatever you want, Levi. Just nice and loud, please.
Matter is made up of solid, liquid, or gas. Solid has a definite size, shade, and color. A liquid becomes the shade of its container. A gas expands to fill its container. This theory of matter might and can also be explained. The liquid to the gas changes of state.
Okay, very good. It's a big hand for Levi. All right, online learners, like I said, feel free to explore as much of that website that interests you. There's a lot of, it says Britannica for kids, but it's pretty scientific. But you might really enjoy this, so you might want to explore it a little bit further. All right, online learners, we will see you tomorrow. Quiz Friday. Bye-bye.